All right. Now question 14. So here we're given a function, and we are supposed to find all points at which the direction of the maximum rate of change is I plus j. Well, first of all, so what is I plus j? So I plus j is just the vector 1, 1, right? So the maximum rate of change of the function, the direction of the maximum rate of change is the given direction. And we know that the direction of the maximum rate of change is parallel to the vector gradient of f, right? So in other words, the question asks us to find um, all points, say xy, at which nebula f of xy is parallel to the given vector 1, 1. Now, generally speaking, how do we decide if two vectors are parallel? So let me just kind of do a bit of digression here. So um, if you have two vectors, say u1 and u2, so this is the first vector with entries u1, u2, and suppose that you want to figure out whether it is parallel to some other vector v1, v2. What does it mean? So parallel means that these two vectors are proportional. So u1 is something like k v1, and u2 is something like k v2, where k is some constant, right? But then solving for k, we see that k is u1 divided by v1, and it also equals u2 divided by v2, right? So this is the condition that two vectors are parallel. To find out if two vectors are parallel, we just check this. Or if you prefer, so we can move, we can change this into the form u1 v2 minus u2 v1 is 0. So this is probably a slightly better form because it works even if v1 and v2 are 0. Well, and if you know a linear algebra, then this condition just means that the determinant of the matrix, if you form a matrix out of your two vectors, say u1 and u2, and v1, v2, so this determinant is 0. Okay, so this is how we verify that two vectors are parallel, right? So what we know is that nebula f should be parallel to the vector 1, 1. Yeah, so at which the direction of the maximum rate of change of the function is the given one. Well, but that's not all, right? Because nebula f, um, so the opposite direction is also parallel to 1, 1, right? So we need to check that nebula, we need to make sure that nebula f is not only parallel to 1, 1, but the coefficient of proportionality is positive, right? So which, and since the vector 1, 1 has positive entries, it just means that nebula f should also have positive entries. So the first partial derivative should be positive. Well, and of course, the second partial derivative is going to be automatically positive because, I mean, if nebula f is proportional to 1, 1, it just means that, well, they have the same sign. Otherwise, they wouldn't be proportional. Okay, so let's find nebula f then. So now we can solve this question. So the partial derivative of f with respect to x is 2x minus 2. Yeah. Partial derivative of f with respect to y is 2y minus 4. Okay, so this is my nebula. So it should be parallel to the vector 1, 1, right? So this should be something like k times 1, and this should be something like k times 1 also. Or again, if you want to use, say, this condition, then it's going to be like this. So 2x minus 2 divided by 1 equals 2y minus 4 divided by also 1. I mean, of course, I didn't have to actually divide by 1 because, yeah, but, if instead of 1, 1, you had some other vector like 3 and minus 7, then instead of 1, 1, you would insert 3 and minus 7, basically. All right, so and now we just need to solve for, well, this is in fact a linear equation, so the answer is going to be like a straight line. It's not just a single point, if you notice, right? So we can just solve it, right? So division by 1, of course, I can just remove it. Um, yeah, then I guess I can move 2y over to the left-hand side and minus 4 to the left-hand side. So then I'm going to get 2x minus 2y minus 2 plus 2 is 0, or x minus y plus 1 is 0, right? So basically all the points along this line, so this is a straight line. So all the points along this straight line, they satisfy this condition that if you take the gradient vector to the given function at every point that is on that line, then that gradient vector is going to be parallel to the vector 1, 1, right? So at any point on that line. So for example, if you take the gradient vector at the point, I don't know, 32.5 and 33.5. So this is a point on the given line, right? So if you compute the gradient at that point, so it is going to be parallel to the vector 1, 1, just like at any other point. But that's not it. So as I already said, so the second condition is that fx, so the partial derivative with respect to x, should be positive. Well, for y, it did the same thing, but it is going to be automatically positive, right? So I should write that 2x minus 2 is positive. So I guess 2x is bigger than 2. So x is bigger than 1. And so this is the second condition. So x is bigger than 1. So it's not the whole line, it's just half of a line. Half the line.